Let's answer question 1. So first we determine the velocity function. We write velocity function, and this is basically the rate of change of the height function, that is h prime of x. So let's find the h prime of x. For this we have to find the derivative of the height function. So I'm going to find the derivative of each of the terms. The first term we have negative 2.65 x squared, and we have to find the derivative of x squared, which is 2x, plus the second term is 210x. So I put the constant as it is, and the derivative of x is 1. So this reduces to negative 2.65 times 2, and this equals negative 5.3. We then have x, it is negative 5.3x plus 210. And so this is the velocity function at any time x. Let's answer question 2. Here we determine at what time the velocity equals 0. That is, we ask the question v of x equal to 0 at what time. That is, we have to find x when v of x equals 0. So I'm going to plug in v of x equal to 0 into the velocity function which we determine in question 1, and find the corresponding x. So when I plug in v of x equal to 0, I get 0 equals negative 5.3x plus 210. I subtract 210 from both sides, so I will get negative 210, and this equals negative 5.3x. So solving this, we get x equals 210 divided by 5.3. Because this negative and this negative, we can cancel them on the both sides. So this gets approximately 39.622. This is 39.622. So, or approximately, we can say that this is 40 seconds. In question 3, we determine the greatest height the arrow reaches. We know that the arrow reaches when the greatest height when the velocity equals 0. So when the velocity equals 0, it is at the time x equal to 40 seconds, the velocity is 0. So I'm going to plug in x equal to 40 into the height function to determine the greatest height. So therefore we get h of 40, and this equals negative 2.65 times 40 square plus 210 times 40. And when we plug this into the calculator, we approximately get 4160, and this is in feet. So this is the greatest height reached by the arrow. Let's do question 4. So here we have to determine how long the arrow will be aloft. The arrow will be aloft for the time when for the time duration when the height is not 0. So first I'm going to set up the height equation 0 and determine the time duration for which the height is 0. So we have to plug in h of x equals 0, and when we do that, we get 0 equals negative 2.65 x squared plus 210x. I'm going to factor x from the right side expression. So I will get negative 2.65x plus 210. So solving this, we get two solutions for x, that is x equal to 0 or negative 2.65x plus 210 equal to 0. So solving this, we get x equals 210 divided by 2.65. Let's plug it into the calculator. I get 79.24. This is approximately 79.24, or we say that approximately 79 seconds. So for x equal to 0, that is when time equal to 0 and time equals 79 seconds, the height of the arrow is 0. And this means for this duration, that is from 0 to 79, which is approximately 79 seconds, the arrow will be aloft. So we say that arrow will be aloft for approximately 79 seconds. Let's answer question 5. So here we have to determine the acceleration, which is given as a of x equals the derivative of the velocity function. So I'm going to find the derivative of the velocity function. That is, we have negative 5.3x plus 210. We should find its derivative. So I'm going to find the derivative of each of the term. The first term is negative 5.3x. So I put the constant negative 5.3, and finding the derivative of x, we get 1 plus the next term is 210. The derivative of 210 is a constant, so it is 0. So we get only negative 5.3. So this is the acceleration of the arrow.